Hey everyone, thank you for joining and welcome to the Cloud Trust Summit 2025. My name is Brian Rosensteel. I am the head of public sector PMM or product marketing management for Wiz. As the title suggests, we're really going to be talking a lot about risk. We're going to talk about what risk actually means from definition perspective and how you can automate a lot of your risk assessment processes utilizing something called a CNAPP, Cloud Native Application Protection Platform. Now, before we get into that, a little bit of a history lesson. So this photo here, this is of what's known as the ENIAC. This is in what is generally considered the first Turing complete computer or first modern computer. And in some ways, where we are with security today came from kind of these humble beginnings within, a true brick and mortar structure of the entire compute power of the world at the time, where you could go in and do an inventory assessment of every wire, every tube, every individual who came in, everything that was being run. You were able to really combine both that physical assessment with the logical assessment for computing. Now, when you contrast this with the world we live in today, this is a different image. This is of just a data center, right? So, and I say it's a data center because our world is filled with data centers across all kinds of different geographic regions, not just within these US, but globally and worldwide. And we moved from that beginning of everything being self-contained and we could walk down the aisle to now we don't even know which data center our data may reside within. We know a geographic region, but that region is comprised of multiple data centers connected together that then comprise kind of the computing infrastructure to where our cloud compute models exist. It's just fundamentally different from where we were. When we think about it in general, that kind of change, it's one of the many reasons why cloud and AI are the biggest transformation security has experienced, right? Cloud fundamentally changed the way that we need to think about security, and AI has really amped that up to the next level. When we look at this kind of complexity and these changes, we can break them down into very, simple general areas, right? New environment with complex systems and pipelines, new risks where data itself, there's an entirely different way of thinking about data leakage. Think about that from an AI standpoint. We can have it where it's not just an external threat actor coming in or internal threat actor to go after, these data, but if we're inadvertently training the AI on the wrong data model, we can actually leak that data out and exfiltrate it out ourselves in an unintentional manner. Very different way of having to think about things. In addition, we also have differences with what we have to uplift from a skills perspective. So we don't have this ability of having a bench of individuals who have been working with these technologies for decades because it hasn't existed. 10 years ago, the cloud looked fundamentally different than how it does today. AI was fundamentally different than how it is today. And so we need to make sure that we are in some way keeping up with the rapid pace of technology, understanding that it's very difficult to find true experts within it. At the same time, we have to balance compliance as well as speed to deployment. And these have always been in contrast with one another. When we think about the speed to deployment aspect, especially when we think about cloud computing, this has evolved out of agile development cycles, quick sprint cycles, quick code delivery. Code itself has fundamentally changed. It's more of a blueprint than, a full kind of end-to-end representation of that workload, because we're going to build a small piece and we're going to then deploy it against functional elements that are already deployed, microservices, et cetera. When we contrast that with compliance, compliance was built around, I need to know everything that's going on, everything that it touches. So freeze the environment, freeze the code. Let me go through the authorization process. That used to work when we had the time to do so. And, if we had to do manual data collection and reporting, et cetera, if we had to leverage legacy technologies like spreadsheets to do this correlation, we could do so because the time to deployment, was something that we could measure in months or even years. DevOps doesn't work that way. You need to be able to have a sprint cycle every few weeks at, sometimes at the longest. So how do we balance this together? How do we make this work? One of the things that we need to do when we look at that dynamic is we actually need to, I think, have a little bit of a level set of what risk actually is. So I pulled definitions here. This is actually from the NIST Risk Management Framework. What you'll notice in these definitions, nowhere does it say anything about a vulnerability or a misconfiguration or an exposed secret or, drift from, a STIG from a configuration benchmark standpoint. Instead, the definition of risk is a little bit different. It's a measure of the extent to which an entity is threatened by a potential circumstance or event, right? A function of magnitude of impact or harm against the likelihood of occurrence. So I'm paraphrasing slightly on it. And a risk assessment is really looking at the indicators of risk. That's your vulnerability, your exposed secrets, etc., to really be able to make that understanding of, what could happen for impact for the operation of that system. And that gives you then that understanding of this is the risk. These are the most critical risks, etc. I think that's really important because I think the way that we've gotten ourselves in the situation where we have this pushback between compliance versus security has come from this notion of, well, compliance means give me a list of all the vulnerabilities that are out there. Give me a list of every, system scan so I could check against certain stakes. That's not risk. As we see, risk is that function of magnitude of impact or harm. In order to do a proper risk assessment, we have to actually look at the entire system to understand what connects together, what the impact or harm could be. In the cloud, that means we need to actually understand our foundational cloud resources. We need to know what's going on at the networking layer. We need to know what's going on in the application and workload layers, in the identity layers, and in the data layers. And we need to be able to trace that back to the source code and the various dependencies. And from that broader visibility, we need to understand the context of how things connect together. And that's something that we've been struggling fundamentally against within the cloud environment. So we need to be able to do this, and we need to be able to do this at scale and very efficiently and very, very quickly. In order to achieve that, there's another thing that we have to be able to fundamentally wrap our heads around. And that's the fact that cloud changes everything. Development being agile and continuous. So we used to have where you could package things up, you deploy it, it's in a directory, in an executable, right? And that's the entire application. Now things are spread across code and pipeline and cloud and runtime. They're actually horizontally connected together, where there are snippets of each that make up the broader workload. You can no longer look at one thing and truly understand the entire, environment or entire workload that you're running. Now, it's important to think about it from a horizontal aspect because that's how attackers are viewing the environment. They're coming in horizontally. They're looking for the vulnerable exposure, jumping over into the workloads, moving over to privileged or excessively privileged admin accounts, and then using that to try to find where the sensitive data resides. That horizontal, that lateral movement through the environment is how they think. Fortunately, it is not how our security has been built. Think back to the days of the ENIAC, right? We're still very siloed organizationally in how we operate, where we have different scanners for code and pipeline and cloud and runtime, causing duplication of alerts and events. We know that this is a problem. So historically, how have we tried to address it? We tend to take all of this information and we pretty much dump it onto a couple of teams. We say you sort it out. This is the reason why in our authorization processes, we tend to freeze the entire environment. Some of these, can take 6 or even up to 18 months. But the reality is we don't have the capacity to keep trying to do this. It's the reason why these timelines are taking longer and longer for these authorizations. And yet we're gone through multiple processes and multiple rounds of trying to innovate. This isn't something where it's like in the future there will be a gap. The reality is the gap is already occurring. Cloud computing models and capacities have been growing at an exponential rate, while our security team capacity, if we are lucky, has been growing at a more of a linear rate. If we were able to add additional people into our organization, we're not able to do so at an exponential capacity. The reality is that I spoke with an agency fairly recently, and I said, "How are you doing your internal risk assessments?" And they told me they're not. They're so overwhelmed that their security team cannot keep up. They're relying entirely on external audits. The gap is something that has already occurred, and our security teams are not able to simply even just keep the lights on. Things are unfortunately being missed. We have to fix this. We have to move from this vertical waterfall, if you will, type of siloed security to a horizontal model where we have different scanners, sure, but those scanners are built for the same unified platform, the same unified system, going into the same backend database with shared cloud and runtime context that then we can use to tease out the information we need to give out to the relevant parties. We have to move our security to an agile methodology, away from this vertical kind of siloed methodology where we've historically been. The way this ends up operating is this new operating model takes all of these different previously siloed scanning tools and really consolidates them together to now I'm able to see, okay, what's going on within networking and the data layers and the identity layers within, my workload layers, and where are my indicators of risk where I have vulnerabilities or exposed secrets, and pull that information together. By that very nature, I'm already deduplicating alerts. I'm reducing noise because I'm not just chasing every vulnerability or CVE that's out there. Instead, I'm looking at how they connect together and then doing an automated risk assessment and saying, this is the actual toxic combination. This represents your issue, your risk. Now that I have that information, I can then disseminate it down accordingly to different teams. I can send the context of the broader risk, of the broader issue, with the relevant information for that area of responsibility for the different individuals involved in that particular mission or that particular project. So 2 quick examples of how this can operate, right? So I've got this combined context together, and then I'm able to notify relevant teams. In this example, I've got a vulnerability on a VM that has sensitive data access, right? So I should be notifying, of course, my development team that is responsible for the upkeep of that particular VM, but I also need to let my vulnerability team know, hey, we identified a particular vulnerability in the environment. You're going to need to track it for your various reporting purposes. And we have to notify the data security team because there is sensitive data access. Let's make sure that this wasn't just something that was a potential, but let's make sure that data wasn't accidentally exfiltrated out or that there wasn't some sort of attack involved. Notice I don't necessarily have to involve everyone across my organization. So even though I have this unified back end, I'm not then going out and alerting everyone in the organization every time there's an issue. We need to reduce the alert fatigue and only notify those that are relevant. So if I have a different issue, different risk, in this case, a code repo with clear text active cloud keys, and it's granting access to an S3 bucket with sensitive data, I still need to notify my dev team to get it remediated back in code, in that code repo. But it's a different dev team. So I can make the system smart enough to where I know, okay, this dev team's area of responsibility covers these projects. So I can actually more accurately direct where the alert needs to go to the right team so I have a faster response time. In addition, I need to alert my data security team because, again, sensitive data access, and my cloud security team because we do have those cloud keys granting that access to the S3 bucket. They need to be aware, make sure that that's being fixed as well. But notice there's no vulnerability involved. So I don't need to notify that vulnerability team. I don't need to involve other parts of the team. So it's a notion of moving from waterfall, vertical security over to this horizontal security while still acknowledging that our organization is made up of different groups. So we need to make sure that our tool is built to be able to adapt to the culture of our organizations versus having to readapt our culture for an individual tool. That never works. That's where we get this constant pushback. Well, you need to meet me how I operate. So let's make sure that we can automate our security tooling to be able to do exactly that. And that's really what a CNAPP is able to do for organizations. CNAPP being the Cloud Native Application Protection Platform. It takes previously, kind of individual point scanners and, unifies those into where those different scans are being put into the same backend graph database. That graph database is very, very accurate at being able to understand the context of how things connect together to help with that comprehensive risk assessment. That allows you to start getting that complete visibility and inventory that you need for that continuous monitoring aspect. And then disseminate that information down accordingly to the various, business units. We call this democratizing security. A good CNAPP should have, active users that are comprised from across your organization, not just the security teams. Now, this is where we're being very proactive. We're looking at, okay, this is what you have to deploy. This is where you have your greatest potential for harm, right? This is where your risk resides. Let's proactively remediate. We also want to be able to prevent those from being deployed in the first place. So this is where we can build securely by design, put guardrails down in that secure supply chain. with the same scanner, same policy, same frameworks across our software development lifecycle. Now, at the same time, it's great if we can prevent every single risk from ever occurring. That would be amazing. Or in the very least, if we can be proactive and identify and shut down the various attack pathways before an attacker has a chance to exploit. But the reality is that we need to also make sure we can be reactive. Now, when we have all of this information within that graph database, it allows us to enrich the events from our logs and our sensors and, various other things that we can ingest in with that cloud context for greater threat detection, for higher fidelity threat alerts, for better response flows, for better understanding of potential blast radius, and for faster execution for things like the minor attack framework, executing kill chains, etc. So we're really helping to empower our SOC, our cyber defense team. And all of these should be able to work together. And a CNAPP is really built to do that, to where we have this context from cloud back to code and code to cloud to runtime, to where all of this is working together in a more of a continuous motion. So we don't necessarily have to, every so often freeze the entire system to rescan the whole system and understand what's going on, because this is a dynamic, ever, evolving view of the risks within the environment that then you can use to pull the information out on a routine basis, not something that should take you months. In fact, this is something that's being used by organizations today. Now, you might say, well, it's great that you can do that, but what about the documentation? So these organizations have leveraged this kind of tool consolidation, this greater visibility with context that you can pull, and this ability to drive that democratization of security through that CNAPP, that Cloud Native Application Protection Platform. And utilizing, because a good CNAPP should be built around, this ability for open standards with a RESTful API interface to connect over to their GRC platform, their governance, risk, and compliance platform, which now the technical elements that are involved within an SSP or within, a SAR or POAM, those can be automated. And so some organizations within the government that have been early adopters to this technology have actually sped up their processes from where it's taking them a matter of 6 to 18 months to introduce new technologies to less than 30 days. That's the transformational power when you move to this model that you can be able to see real gains and start moving towards that speed to deployment that we need to be at to be able to keep up with the demands of the threat landscape as well as mission needs for the world that we operate in. I'd love to go back to where everything was just back in those single data centers, back in the ENIAC days. But that's not the needs, and that's not how the world operates today. So this last piece that I'll kind of leave you with is really this success criteria. Then you can build out of this new operating model, truly knowing your environment, making sure your risks are actually prioritized, and more importantly, actionable, that action can be taken very quickly to fix the critical risks first, and that you're empowering your dev and your SOC teams while making sure that you have a working model that scales very quickly and efficiently across your entire environment, across your entire organization. So thank you very much. Hopefully this did help you to kind of understand the art of the possible that actually can be done today within your cloud environments. If you want to know more about how you can automate this visibility, how you can prioritize your risk assessment over just vulnerability reporting and moving to this continuous monitoring, recommend that you reach out. We're happy to carry on that conversation.